Okay, we have the parent function that is a quadratic function, and I have this table of values. My domain is not from negative infinity to infinity. I restrict it from negative 4 to 4. So when x is negative 4, y is 16. When x is positive 4, y is 16. This is my parabola for my parent function. Now I am transforming and I am saying, hey, I am going to find the y for g is going to be the same for the y of 2 times x. Okay, what is that value? Let's see. The y has to be the same. Look at the highest value that I have. The highest value that I have is 16. If I do a table for g of x, I started with negative 4. The same x that f of x. But look at the y. Negative 4 times 2 is negative 8. Negative 8 exponent 2 is 64. Do I have 64? Do I have a y available that is 64? No, the higher value that I have is 16. So I cannot work with negative 4. I cannot work with positive 4. However, when the x for g is 2, the value is 16. I can get to 16 because those y's, the maximum should be 16 for this domain. So let's plot these values. Let me change the color. So when x is 2, y is 16. When x is negative 2, y is 16. When x is 0, y is 0. This is the graph of the transformation. Sorry, it's not so accurate. What happened with the domain? Did I have any value passing through? No. Any value before negative 2? No. So my domain went from negative 2 to positive 2. That's the domain of the transformation. And you see, this is a compression, a horizontal compression by a factor of 2. By a factor of 2. We are going to explain a little more the tables. So give me a second. If I look at the parent function absolute value of x, and I make this table, when x is negative 6, I complete my table until x is 6. That's my domain. If I use the same domain for g of x, 2 times x, and I said that y has to be the same, okay? The y, I have a g of x is equal f of 2 times x. The y's are the same. When I graph my parent function, I have 2, 4, 6, 8, 10, 12. Okay, when x is negative 6, I have 6. When x is negative 4, 4, negative 2, 2, 0. And I have the symmetry to the side. Okay, this is my absolute value. Sorry, it's not so accurate. But this is my domain from negative 6 to 6. The higher value that I have for my y is 6. And I cannot exceed that value because the y, remember g of x is the y, has to have the same y for the f. I don't have another possibility. So the higher that I can go is 6. So I can only get to negative 3 until positive 3. The other values are not possible. So my domain goes from -3 and 3. Look how they change. I multiply by 2 dx. My domain is divided, the values are divided by 2. Divided by 2. And let's graph this new function. Let's graph g of x. How does it look? Okay, remember we start with -3. So when x is -3, we have 6. When x is -3, I have 6, here is -3. When x is +3, 3. When x is -2, I have 4. So this is not a stretch, it's a compression. Why is a compression? Because the domain was shrinking. The domain was compressed. My domain before was at -6. It moved to -3. So that's a compression. A horizontal compression when the number multiplying x is greater than 1. When this number, let's call this number, usually the correct case, is greater than 1. That's a horizontal compression.